Hi guys, welcome for this video. Guys, I hope you are fine. I too am fine. I hope that God has kept you well and that you are safe. We want to thank God for yet another opportunity that He has given to us to come and learn together engineering mathematics. And so we can say it is God who has helped us. And so we thank Him. Yes, the Word of God says we give thanks to God all the time. And so guys, as we go to this lesson, let's see what the lesson has in store for us. And so we start, guys. The question reads, evaluate the integral. And so guys, I can start now to do the question. The first thing we shall do is to, because it has one fraction with like two, we can say the way it is, we are supposed to separate it to become a simpler partial fraction, that is fractions. That is to say, guys, we are going to have two fractions which are simpler as compared to one which is a bit complicated. And so guys, we come and say we now first of all separate it into partial fractions. So I say 1, I'll leave out dx first of all because I'm not integrating right now. So I say 1 all over x squared plus 1 is equals to, now we write this in partial fractions, like that, like that. So down here we are going to have x first, down here we are having x squared plus 1. Here we shall have our a, because what happens, the numerator always has the variable x being raised to a lower value than the one in the denominator. For example, now this one is like a multiplied by x raised to 0, but x raised to 0 is 1. For this one you have b, then x raised to a number that is lower than 2, which is 1. Then you have to go ahead and say c now, like that. To give an example, guys, if you have, for example, let me divide here, there. If you have a number here, let's say it's x cubed plus 2, like that. That is our denominator. Then you shall have here, we'll have your numerator as b x squared plus c x plus d. So that's what happens. You make sure that this is a polynomial with reducing values of x, or the number that raises x, they are on the reducing value. So for us here now, we have this. So guys, we continue. From there now, guys, we shall have this one. We are now going to find to expand this. So you shall have 1 here will now be equal to, you divide x, you divide this by x. That one is going to be a, just like the normal way we do if we are looking for, we are evaluating fractions. X squared plus 1, then plus b. This one is, this divided by that, it will be x, bx plus c, like that. Then we can expand it. This will be ax squared plus a plus bx squared plus cx, like that, guys. On this other side we have 1. But remember, guys, we have coefficient for x squared here, which is a, and we have coefficient for x, which is c. So on this other side, we can now write in terms of this, like something that is almost equivalent to this on this other side. So this one will be, we will have 0 x squared plus 0 x, like that, guys, because we know that this side we don't have any other value apart from 1. So the coefficient of x squared will be 0, the coefficient of x will be 0. So this one now will come to, we can now find about the coefficients now for x squared. This now is going to be, for this side we have 0 coefficient of x squared. For this side we'll have a plus b, like that, because here, guys, a plus b, we have x squared there, and this one we also have x squared. So a plus b must be equal to 0, guys. So it's going to be 0 is equals to a plus b. Let's now go to coefficient of x. Coefficient of x is going to be, this side is going to be 0 x, this is x there, guys. Coefficient is 0, that the variable is x there. This is equals to, for this other side it is going to be c, and this, it has now, it's x there now, guys. So we shall have 0 is equals to c. So already we know that 0 is equals to c. We continue, guys. So guys, we continue now by replacing our values that we have found out. So we shall, I can maybe repeat this one and now write it in partial fractions. So let's see how I will write it now. So this one is going to be equal to, or I can say integral 1 to 2, then dx all over x squared plus 1 can now be written as equal to integral 1 to 2, and I write a, which is 1, that is now dx. 1, I don't have to write 1 there. It's quite okay, because even without 1, 1 is there. So this one is now going to be x, like that, plus integral from 1 to 2 of now bx Now we can find the bx there. B is supposed to be -1. -1 x. Now we write dx there. All over x squared plus 1. So therefore, guys, we are now going to evaluate these two, because this is what now we require after we have divided this fraction into two partial fractions. So we are going to integrate these two, guys. So let's start now the process of integration, guys. So we shall have now integral of dx over x gives us ln x, like that. Limit 1 to 2. Then this one is now going to be negative. Can write it again, guys, before we integrate. Limit 1 to 2. Here we have x. We don't have now to write 1 again. Dx all over x squared plus 1. Now, guys, remembering this from our definition of integrals, let me show you now, guys. We have, if you integrate fx, that is f prime x, all over fx, this one now gives us ln fx, like that. That is our integral for that. Now plus c for indefinite. So, guys, here is an illustration for that, meaning that the differentiation of this, it is this f prime x. So this one is the fx. F prime is now supposed to be differentiation of this, which is 2x. And so, guys, we shall have to modify this one to look to be the differentiation for that. So I write 2 here, so that now we know the differentiation for that is this. But now if I write 2, I have changed the equation. So, guys, I have to divide by 1 over 2. So from there, guys, we can now be able to integrate. And this is how we do it, guys. Now this one is now going to be, we repeat that one again because it's still there, ln x. You have limit 1 to 2. This one now is going to be minus 1 half, and then just like that, like this, it will be ln x squared plus 1, like that, guys. Limit 1 to 2. So this is what now, guys, we are dealing with. So we continue. This one now will be, if we replace 2, this for this one, it will be ln2, like that, minus ln1, like that, minus, we can replace for 2, that is 5. It will be, let me put it like this, guys, like that. This will be, I have ln5, now minus, this minus is not this, it is actually after I have replaced the whole of this to be now 2 times 2, 4 plus 1, 5, minus, I have ln, now 1 is going to be 1 plus 1, that is 2. guys. So finally guys, we shall have something like this. ln2 minus ln1 minus, now I have ln5 plus, now because this is minus and minus, I have ln2. So I can evaluate this figure offline and then I can come back to you. So guys, these are the values I have found after the calculations using the calculators. So now we have to add them up and see what we get. My final one was 0.346. So I add to 0.693, then minus 0.804, 0.804, and my answer is 0.235 guys. And then guys, this is now our final solution. So guys, we can say that maybe to light it afresh, this now is going to give us integral of 1 limit 1 and 2 dx all over x squared plus 1. This one now gives us this figure 0.235. And so guys, that is our solution. So guys, welcome and thank you for being together with me. So this is how that problem has been evaluated, like that. You can see it is well done. I hope all of you understand. I believe all of you are understands and can be able to follow. So this is how it is supposed to be done, guys. And guys, thank you for being together with me and for allowing me to be your trainer as of today. And as of the rest of the days, I shall be training you. So thank you guys. Welcome. God bless you.